In the midst of groundbreaking ventures like revolutionizing the electric vehicle industry and advancing space exploration, Elon Musk has made an unexpected announcement. One tied to one of the most historic space missions of all time, the Voyager program. As a self-proclaimed science enthusiast, Musk's recent comments have stunned the scientific community and rekindled global curiosity about these legendary spacecraft. In a recent statement, Musk reflected on the future of the twin Voyager probes and shared his thoughts on how long they might continue their remarkable journey through deep space. But more than that, he unveiled a jaw-dropping space revelation that has sparked widespread intrigue. It was a call to embark on an unprecedented interstellar adventure. When Elon Musk was just 6 years old, NASA launched Voyager 1 and Voyager 2. Spacecraft that would eventually become icons of human curiosity and endurance. Musk feels a deep, personal connection to these spacecraft. After all, his own rockets now launch from the same Cape Canaveral site in Florida where the Voyagers began their historic missions. More than 50 years later, the fact that both probes are still active is nothing short of astonishing. At the time of their launch, no one could have imagined they'd still be functioning today. Originally designed for just a 4-year mission, the Voyagers have far exceeded expectations, continuing to return invaluable data from the edge of our solar system and beyond. What many don't know is that the entire Voyager mission depended on a rare planetary alignment, an alignment of Jupiter, Saturn, Uranus, and Neptune that occurs only once every 176 years. The last time it happened was during the early 1800s, around the time of Thomas Jefferson. This alignment allowed the probes to use gravitational assists from each planet, effectively slingshotting themselves through space. Think of it like an invisible thread tugging them forward, each planet giving them a powerful boost. This brilliant strategy, devised by NASA engineer Gary Flandreau, reduced the travel time from Earth to Neptune from 30 years to just 12. Realizing they couldn't afford to miss this once-in-a-lifetime opportunity, NASA decided to launch not one but two identical spacecraft, Voyager 1 and Voyager 2. These probes, each about the size of an old Volkswagen Beetle, were equipped with 69 kilobyte computers. Yes, kilobytes, not gigabytes. By today's standards, even a modern car key fob has more processing power. And yet, these tiny computing systems managed one of humanity's greatest feats of exploration. Instead of modern storage, they had 8-track tape recorders to store scientific data. Their transmitters operated with the power of a refrigerator light bulb. To compensate, the spacecraft were equipped with 12-foot wide high-gain dish antennas capable of sending and receiving faint signals over billions of kilometers. Since their launch in 1977, the Voyagers have made some of the most groundbreaking discoveries in space exploration. Voyager 1, for instance, holds the record as the farthest human-made object from Earth, now journeying through interstellar space. But survival out there isn't easy. The temperatures are near absolute zero, and radiation levels are immense. Solar panels are useless that far from the sun, so each Voyager relies on thermoelectric generators, or RTGs. These power sources convert heat from the radioactive decay of plutonium-238 into electricity. At launch, each Voyager generated around 470 watts of power. That has decreased over time, but even now, these aging RTGs still produce enough energy to keep critical systems running. It's a testament to the ingenuity of the engineers behind them. In March 1979, after 546 days in space, Voyager 1 arrived at Jupiter. Its twin, Voyager 2, launched a few weeks earlier and reached the gas giant later that same year. Both spacecraft were equipped with high-resolution cameras designed to capture full-color images of the planets and their moons. Because sharp, detailed images were critical, the spacecraft rotated incredibly slowly, about 15 times slower than the second hand on a clock, ensuring that photos remained crystal clear. Even while still months away, Voyager 1 began transmitting images of Jupiter. The detail was astonishing. One of the biggest surprises was Jupiter's moon Io, which turned out to be nothing like Earth's moon. In fact, Io was teeming with volcanic activity, becoming the most volcanically active body ever discovered, 10 times more active than Earth itself. Voyager's instruments also picked up strange charged particles, oxygen and sulfur ions, in quantities never before observed. At first, scientists thought it was a mistake. But further investigation revealed something incredible. Io's violent volcanic eruptions were releasing these particles into space. The most dramatic eruption came from a volcano named Pele, where volcanic plumes rose over 30 times the height of Mount Everest, blanketing an area the size of France. Meanwhile, Europa, another of Jupiter's moons, revealed a cracked icy shell more than 60 miles thick, hinting at the possibility of a vast subsurface ocean. Voyager's cameras took more than 33,000 images of Jupiter and its moons, each one revealing something new and unexpected. Perhaps most surprising of all was the discovery of Jupiter's faint ring system, previously unknown to astronomers. From there, the probes continued their mission. Voyager 1 flew past Saturn and its iconic rings, taking stunning photos and closely observing Titan, Saturn's largest moon. Titan's thick, hazy atmosphere sparked speculation about its potential for harboring the basic chemistry of life. Voyager 2 traveled further still, becoming the only spacecraft to visit Uranus and Neptune. It discovered 10 new moons around Uranus and confirmed that Neptune, like Saturn, had a ring system of its own. When it reached Neptune in 1989, Voyager 2 flew just 2,980 miles above the planet's clouds, closer than any other spacecraft. There, it measured the fastest winds in the solar system, whipping across Neptune at speeds over 1,000 miles per hour. On Triton, Neptune's largest moon, the probe found frigid temperatures of 235 degrees Celsius and ice volcanoes spewing nitrogen gas and dust miles into the air. The discoveries were beyond anyone's imagination. And then came one of Voyager's most poetic contributions. Thanks to the persistence of legendary astronomer Carl Sagan, NASA agreed to turn Voyager 1's camera back toward Earth in 1990, as the spacecraft prepared to shut down its imaging systems. On Valentine's Day, Voyager snapped 60 final images. One of them, known as the pale blue dot, captured Earth from 3.8 billion miles away, a tiny pixel of light suspended in a beam of sunlight. That image forever changed how we see our place in the universe. Today, both Voyager probes remain in communication with Earth, though they drift farther and farther away each day, by about 3 to 4 light-seconds daily. NASA uses its Deep Space Network, with 3 strategically placed tracking centers on Earth, to receive their faint signals. Both spacecraft have crossed the heliopause, the boundary where the Sun's influence ends and interstellar space begins. Voyager 1 entered this region in August 2012, with Voyager 2 following 6 years later. But even now, they continue to surprise. Recently, Voyager 1 sent back signals that puzzled NASA engineers. Its altitude and orientation control data didn't align with expectations. Scientists aren't sure if it's a real anomaly or simply noise caused by a failing system. But the fact that the spacecraft is still functioning at all is a miracle in itself. Elon Musk's recent announcement has sparked renewed interest in the Voyager program. With the rise of private spaceflight and futuristic plans for Mars and beyond, the legacy of these humble probes reminds us of just how far we've come, and how much farther we still have to go. Musk has hinted at a desire to build upon what the Voyager started. Could SpaceX develop a modern interstellar probe? Could we one day build a spacecraft capable of reaching another star system within a human lifetime? These are questions no one can yet answer, but thanks to the Voyager program, we know it's possible to dream. Let us know what you think in the comments below. Could humanity's next leap forward be inspired by the legacy of Voyager? If you enjoyed this journey, don't forget to like the video, subscribe to Discovery at 2.0, and hit the notification bell so you never miss a cosmic update. Until next time, keep looking up.